10.4 hyperbolas. This is the third of the conic sections that we are going to study. I think the best way to get right into this is to draw a picture and start talking about its different parts. I'm gonna do this centered at the origin, and then obviously we can move it. The center is HK. Well, we currently have it at the origin, so that'd be 0, 0, but it does have what you want to call center. Now, from the center, we do have an A and we have a B. The equation, if we moved it, would be x minus h squared over a squared minus y minus k squared over b squared equals 1. Now that's one of the hyperbolas. A and B no longer have to be larger or smaller. Okay, it's just going to matter what comes first. So if x comes first, that's going to be what you draw the your hyperbola on. So since x is first, we have vertices. Okay? So let me go ahead and put those. The vertices will occur on the x-axis because x is first. I don't know what your question was going to be, but for the ellipse, the larger number was always a. This, whatever letter comes first, is where you're going to draw your graph. So there's one set of vertices. That set of vertices will go on the x, and we'll draw the y also. I'll show you that what that looks like. All right, so where is this going to occur? This is going to occur at A0 and negative A0. That's your vertices. Now, where does B come into play? Well, B is going to be up here somewhere. It could be bigger or smaller than A. That doesn't matter anymore. You don't have a major axis or a minor axis. 0B, 0, negative B. Now, if we connect these up with lines that are parallel to the axes, we will form what's called the fundamental rectangle. So the A and the B form the fundamental rectangle. Okay. Now, the fundamental rectangle allows us to draw asymptotes. The hyperbola has two asymptotes. Asymptotes are drawn from the center out through each corner of the fundamental rectangle. So we're just about ready to draw the hyperbola. Let's go back and change something real quick. It's not a big thing. These points for B are really not part of the graph. You don't leave them as an open dot. They do not have any effect on what the graph looks like. The vertices is where we draw the hyperbola from. So the hyperbola starts at the vertices, or A, and gets closer and closer and closer to the asymptotes. There are two curves to the hyperbola. In this case, one on the left and one on the right. Now, the axes where the vertices occur, and I forgot to give you this one, the foci occur, C0 and negative C0. Okay, the foci are inside of that curve. This is called the transverse axes. The transverse axis. In this case, the x-axis would be the transverse axis. We can't refer to it as major or minor anymore because A and B could be very large, and that could be the longer side. That doesn't matter. The other axis is called the conjugate axis. So if they tell you a transverse axis length or conjugate axis length, they tell you that something is occurring on the transverse axis, that will help us determine what letter will come first. The relationship that connects A, B, and C, since we do have foci, is actually the Pythagorean theorem. Slightly different than the ellipse. The ellipse was c squared equals a squared minus b squared. Okay, and again, that's why I gave you the opportunity to use a little index card to help you remember some things. There's a lot to remember here. It might get a little confusing. All right, I think that's everything you could possibly need to know about that hyperbola. Now we're going to draw it again. In this case, instead of the transverse axis being the horizontal, it will now be the vertical. Any questions on this? Everybody pretty much got this copy down? All right. Still centered at HK. And in this case, we're going to have B0, negative B0. Sorry, keep putting solid dots for B. Those are going to be open dots because they're not part of the graph. They just help us form the fundamental rectangle. 0A, negative A. That's going to go with y minus y minus k squared over a squared minus x minus h squared over b squared equals 1. So notice that the a and the b doesn't move. The x and the y switch places. So whatever comes first is what you're going to call your transverse axis, and that's where we're going to draw, okay, the hyperbola. Fundamental rectangle. Which allows us to draw the asymptotes. And we can draw the actual hyperbola approaching the asymptotes. Foci, be inside those, 0, C, 0, negative C. Same relationship ties them together, c squared equals a squared plus b squared. That's not going to change. The only difference is that the graph is now drawn on the vertical axis. So the transverse would be vertical. And the conjugate would be the horizontal. Any questions? All right. If there's no questions, anybody still copying? Good. Take another minute. Get that copy down. Okay. Any questions? All right, let's take a look at a couple examples then. Find the equation of a hyperbola with foci at 7, 1 and 3, negative 1. How about negative 3, 1? Any requests? All right. So where's that? Whose transverse axis is 8 units long? All right, so we have some foci. We have transverse axis length and some romantic music. It's kind of touching.
So, Mr. Gross, how can we tell what the vertices are?
Well, we don't know yet. We're going to find it. Okay? What do we know right now at this point in time? We know 2 points. So let's plot them, see what that tells us, okay? this down a little bit. 7, 1, and negative 3, 1. Right. These are the foci. The foci are located inside of the curve. So, just as a sketch here, should look something like this. Right? It's a really bad sketch, but that's basically where our graph's going to be when we're done. Because the foci have to occur inside that. I'll get rid of those. What can we find if we have the foci? Same if we had the ellipse. Should be able to find the center. Start with the center. Because everything, if you remember from the ellipse, was based off the center. If we can find the center, we can find everything else. So, where would the center occur? Well, hopefully right in the middle of these two. So we can count, we can do the midpoint formula. We're just going to try counting it first. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 10, so we're going to go 5. 1, 2, 3, 4, 5. Looks like the center is occurring at 2, 1. So I already know most of my equation. Is x or y going to come first? Correct. X minus 2 squared over minus y minus 1 squared over equals 1. So all I got to do is find a and b. At this point in time, what do I know? Do I know anything? Not a. Something is 5. Not a. A is not 5. What did we count from to get 5? To the foci. And the foci are C. C is 5. That's what we know so far. Transverse axis length is 8. That means from the center out to the right and left is 8. 1, 2, 3, 4. 1, 2, 3, 4. Those points are going to be what? Yep, vertices. Negative 2, 1, and 6, 1. We know our vertices, and now we know what A is. A equals what? A equals 4. What else are we missing? B. How do we find B? It is the Pythagorean theorem. So, 25 equals 16 plus b squared. Looks like 9 equals b squared. So plus or minus 3 equals b. Correct? So from the center, I'm going to go up 3, down 3. Okay, and we can label those points if we want. That would be 2, negative 2, and 2, 3. What I can draw now is my fundamental rectangle. Again, the fundamental, yes, question?
Shouldn't that be 2, 4?
Did I count wrong? Yes, you're right, 2, 4, I apologize. Thank you. 1, 2, 3, yep, 2, 4. All right, so asymptote from the center out through the corners of the rectangle. Oops, that's not the corner. draw the hyperbola getting closer and closer and closer to his asymptotes, but never touching. We got away from the question at hand. Got so excited in drawing this. What's the equation? What goes first always? A squared. In this case, 16. B squared is 9. There's your equation. And we drew it completely. One other thing that you may be asked to do is find the equation of the asymptotes. Okay, we're going to try to make this as simple as possible. The equation is going from the center out through a corner of the rectangle. So what would the slope of that line be? It's either A over B or B over A. In this case, what would it be? What's that? A over B. How do you find slope? Change in y over change in x, right? Our vertical distance, is that A or B? B. Horizontal distance is going to be A. It's actually going to be B over A. So what's our B? 3. What's our A? 4. So the equation of the asymptotes is going to be, I'm going to leave a little space here. I'm going to show you a little trick. You write down the slope. We're just going to say plus or minus 3 over 4. That actually covers both asymptotes, right? Because this is a plus 3, plus 4, minus 3, plus 4. Plus or minus 3/4 will cover that. B over A. Now, when using a point slope, you have y minus y sub 1, x minus x sub 1. Well, our y sub 1 and our x sub 1 is our center point. That's another point that we have. It's the only point that we know. We could figure out the point of the corner, but we don't need to. So we're going to plug in this point. So y minus 1 equals plus or minus 3/4 x minus 2. That is the equations of the asymptotes. And we could get y by itself if we needed to. We could say y equals plus or minus 3/4 x minus 2 plus 1. And that's probably the better way to go. That's probably going to make more sense. So we could ask you to find the equations of the asymptotes as well. Something that could occur. Any questions on that example? Yeah. How far? Greg?
So what's that bottom part for?
That's the equation of the asymptotes. Slanted line, right? Both slanted lines. I did not ask you. I was just showing you. Oh, absolutely. It could be asked. It could be in a homework. Yep. I've seen that pop up. They may actually give you the equation of the asymptote, which gives away A and B, right? And the center, depending on how complicated it is. Yeah, that gives us the center and A and B. So if they gave us the equation of the asymptotes, that'd give us a lot of information. All right, so I gave you some parts. We found an equation. Let me give you the equation, and let's go ahead and then graph it, okay? Find all of these parts. Everybody ready for that? Find the coordinates. of the center, foci, vertices, what else? And equations of the asymptotes. Or y plus 4 squared over 36 minus x minus 2 squared over 25 equal to 1. Okay, there's three things that we get immediately from the equation. What's one of them? We're all three, if you know them all. Center. Definitely get the center. The center is going to be negative 4. Whoops, I got that backwards. Got to be careful about that. Remember, HK, H always goes with X, so it's going to be 2, negative 4. That's something that we got to really pay attention to that one. You get that mixed up. 2, negative 4. All right, so let's start building a graph already. Negative 4. What else do we know? Yeah, but how do we get that? Actually, take the square root. A squared is 36, right? So A equals plus or minus 6. B squared equals 25. So B equals plus or minus 5. So from the center, we are going to move. Which way? 6. Up, down, left, or right? Up and down. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's going to be 2, 2, and 2, negative 10. And those would be our what? Those are the vertices. 2, 2, 2, negative 10. Okay, so we already have those. B, we're going to go 5 left and right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think they're worth plotting, but they didn't ask us about those points. We need them for the fundamental rectangle. So that's going to be 7, negative 4, and negative 3, negative 4. Correct? Accounting correctly there? No, that's the center. I'll write it over here. We already wrote it, but the center is 2, negative 4. That's something we also need. So the fundamental rectangle can be drawn. The asymptotes can be drawn. And the graph can be drawn. Two things that we don't know yet. How about foci? C squared equals A squared plus B squared. 36 plus 25. What's that? 61. That's not very pretty, is it? I don't even think, does that even reduce? I don't think so. Square root of 61. Nope. So, foci, where do they occur? I'll put this in just to show you. You don't have to put this in. What are we calling this red axis? The red axis is the transverse axis. The blue is the conjugate axis. The foci occur on the transverse axis along with the vertices. Remember, they go inside the curve. So, they're going to be added to what? The center is 2, negative 4. I'm going to add to which one? The x or the y coordinate? What? The y. We're going vertically, right? Vertically. So we're going to take 2, negative 4 plus or minus the square root of 61. And I need some decimals on that. So let's go negative 4 plus the square root of 61, negative 4 minus the square root of 61. All right, getting 3.810 and negative 11.810. So that's our foci, and when we plot them, it should make sense. 2, 3.8. Does that make sense where we put those? They're inside the curves, right? If you would have added to the x, it wouldn't even been on the right? It would have been out in the middle of nowhere. So you'll see that whenever you draw those. So we have center, vertices, foci. What's left? Asymptote. You need the equation of the asymptotes. What's my slope going to be? What's this distance? What's my vertical distance from the center? A or B? What? A in this case, because we're drawing it on the vertical. That's my vertice, that's my A. So A is actually what? What's A? 6. And then my B is what? 5. So it's plus or minus 6/5. What's my center? 2, negative 4. So y plus 4, x minus 2. Again, if you want to get y by itself, y equals plus or minus 6/5 x minus 2 minus 4. I think that's the better way to go there. That's it. That is everything we could possibly find with a hyperbola. Note card's looking pretty good, huh? One. I hope you write small. I do have one more example we could do. I think I'm just going to do the first part of it. I don't think I'm going to do the whole thing. All right? Are there any questions on what we just did, though? I could give you a graph, you find the equation, or give you some parts, you can find the equation. Or I could give you the equation and you can find the parts. There's really not much else you can do. All right? So this next example is simply going to be putting it into the equation into the right form. Find the standard form of 9x squared minus 4y squared minus 54x minus 40y minus 55 equals 0. Now, I could have done much more with this. I could have said, find all of the parts for this equation. And that's how it's going to be given to you in a test. What is this? Obviously, we're studying hyperbolas today, so it's a hyperbola. On the test, it could be anything. How are you going to recognize what it is? That minus sign gives it away. The three general forms we've seen circle, ellipse, and hyperbola. Circle, the coefficients of the squared terms are the same and added together. Ellipse, the coefficients of the squared terms are different and added together. Hyperbola, the coefficients are different and subtracted. You'll see that when we get to the standard form. We're going to do this exact same thing we did with the ellipse. Group the x's, group the y's, move the number over. What can we factor out? What number can we factor out of the x? 9, right? X squared minus 6x, let's go ahead and complete the square, minus 3 quantity squared. What can we factor out of the y? Careful, you want it to be positive x squared, so minus 4. Y squared plus 10y plus 5 squared. Oops. Equals, we got a 55. We have a plus 9 times negative 3 squared. And here's the trick, minus 4 times 5 squared. Whatever number's out front's got to go with it. So we have 9 times x minus 3 squared minus 4 times y plus 5 squared equals, any ideas what that's going to be over there? I'm going to say 36, but why don't you guys go ahead and type it in? No, it's not always 36. It's always, what, oh, did you get 36? Type it in, see what you get. All right, I'll type it in. 55 plus 9 times negative 3 squared minus 4, 5 squared. Why is it 36?
Times 4.
Yep. Same thing as the ellipse, right? Two numbers out front, multiply together, have to equal that. Now we'll divide by 36. X minus 3 squared over 4 minus y plus 5 squared over 9 equals 1. That's the standard form. Clearly it's a hyperbola. We know what a squared is. We know what b squared is. We know what the center is. We know the transverse axis is the x-axis. Conjugate axis would be the y. I'm not going to go through finding all the parts. Okay, we just did that. But we got it to the point where we can now find all of its parts. Okay? If I said just find standard form, if I said find all of its parts, no, you have to find all of its parts. But I want to show you how to convert it in there. Same as ellipse. It's really not any different than we have already seen. So that's it.